Hello guys. This problem was sent to me. I had a question, or a student had a question concerning this particular problem, and I have worked this problem out and realized that I wrote a number wrong. So this is my second time trying to do this. As you can see, it says that the difficulty is hard and that it takes about 6 minutes to work this problem out. Now, this is one of those problems where it's not technically very difficult. It's just that if you don't know how to set it up, it can be difficult if setting the problem up correctly. Is a big piece of the puzzle, and that makes it a whole lot easier. And you have to do better than I did and make sure that you can write so that you can read your handwriting so that you don't make a mistake. Okay? And one way that you can do that, helpful tip, is to use graph paper when you work your problems out so that all of your problems are neat and nice and orderly and you can read what's going on. Okay? So let's work this out. It says a foundation invests $55,000 at simple interest, a part at 7%, twice that at 4%, and the rest at 5.5%. What is the most that the foundation can invest at 4% and be guaranteed $2,950 in interest per year? Okay, so guys, I think two words there that stood out to me, and that is simple interest. As you go through this course, we will have different types of interest problems. And simple interest lets me know that, well, in my mind, simple interest literally means simple. It's not difficult. And different textbooks or websites use different variables. I think that our textbook may use A equals PRT, where A is the amount in interest, or you may see I, as in the simple interest, equals PRT. So what does the P, the R, and the T stand for? Your principal, your rate, and your time. So those are three things that we need to be able to determine what our simple interest is going to be that's accumulated. So I need a principal, I need a rate, and I need a time. Well, what makes this problem difficult is that we technically have three different principles here. We have a total amount here of 55,000. But of that 55,000, I am going to invest a part at 7%. So this is one of those things where I said if you haven't worked these type of problems out before, this is what is very helpful, understanding that you probably need a table for this part of this step of the problem. So principal, that first principle, all it says is I am investing a part. I don't know what that part is. It's an unknown. And in math, when we have an unknown, we use a variable, right? So my unknown there, I'm going to notate that unknown as N. It's an unknown amount that N. I'm letting that represent what I do not know. So that unknown amount, it's going to be a part invested at 7%. That is a percent, which is that is my interest rate, right? But with these types of problems, we cannot use the interest rate, in percentage form. I need to change that percentage to a decimal form, which means I need to move that decimal over 2 times. So that would be 0.07. And my time here, all of these, we're investing at the same time, right? And at the very end, it says, and be guaranteed $2,950 in interest per year. So that time is 1 year, right? So let's move along before we do anything else. So that second piece here, it says then twice that amount at 4%. Well, look, I have no clue what that first amount was. I put in there because I didn't know. And I did math long enough to know that if I don't know something, I can stick a variable in there for what I do not know, and I can solve for it later. Well, now it's telling me that that unknown amount that I do not know, that I'm going to double that amount. Okay, well, that's fine. If my first unknown amount is N, Well, then what is double that? What is twice n? It's 2n. So I'm going to put 2n there, right? So that twice n, that twice that amount, the interest rate that I'm going to apply to that piece of the money is going to be 4%. And we're going to do the same thing again. Change that percentage to decimal form, which would be 0.04. And again, that's after 1 year per year. And I'm going to leave the last piece blank for the moment. And this last bit is kind of the hard part. And usually students can kind of get that first piece. It's this last piece we might have trouble with from my experience. So it says the rest of the money that I have not already invested, I'm going to invest that at 5.5%. Well, let's go ahead and put the 5.5%, change that to a decimal. That's going to be 0.055 at 1 year. But what is the amount that is left? Well, I started out with 55,000. I used N amount of dollars already. Or the foundation did. They invested N amount of dollars at 7%. I have to take that much away from the 55,000. Then I invested twice that amount. So I want to take the amount that I took away the first time, I'm going to take away twice that much the second time. And I'm investing that much at 4%. So this notates right here what I have left. What I have left is what's left after the N minus the 2N is taken away from that original 55,000. So combine your like terms. That's going to be 55,000 minus 3N. So this, guys, right here notates what is left of the money after those first two investments have already been made. So what is my principal? My principal is that 55,000 minus 3n. So why do I need all of that? Well, I've got to find my simple interest for each one of these. So my simple interest, can I put A is equal to PRT? So my A here is going to be equal to my P, my R, and my T, which is just going to be 0.07n. Okay, again, my P, my R, and my T is going to be equal to 0.08n. Okay. And this last piece is that my P, my principal, times my rate times my time. And if I simplify that, if I multiply this, let's simplify this using my distributive property. I know that 1 times anything, that 1 does not change the value of the number. So I'm not really going to worry about that 1 that's there, but I'm going to multiply, and I'm going to use my calculator because I don't want to mess up these numbers for you guys. If I multiply that 0.055 times that 55,000, I'm just going to write that up under here. This would be 3,025 minus, and if I multiply that 0.055 times 3, that is going to give me 0.165n. Now, why is that helpful? Well, the problem said that when I take all of these interest rates that I have here, which is the 0.07n and the 0.08n and the 3,025 minus 0.165n, when I add those together, look at that word problem there, I want to be guaranteed that 2,950, which means I can have more than that, but I definitely do not want to have less than 2,950. So in other words, I want to have greater than or equal to 2,950. I want to have no less than $2,950 accumulated in simple interest once I add all of this interest together. Okay, so that is it. That is your inequality problem. So in chapter 1, section 6, you've been working with inequalities, and there it is in the problem. So from here, it's literally basic algebra. You combine like terms and solve for the variable. And I'm running out of time because I have a time limit on these videos. But let's see if we can solve this really quickly. Let's combine like terms, and I'm going to use my calculator, which I hope you guys will, because at this point in math, calculators, um, they are very helpful, and they make the adding and subtracting and the basic operations in math, they make them a little bit easier for us. So if I combine those like terms, that 0.07, 0.08, 0.165, that would give me a negative 0.015n plus 3,025. That would be greater than or equal to 2,950. We are solving for n, which means I need to isolate n. So what I'm going to do is I'm going to move that 3,025 to the other side of that inequality. And when I subtract it from both sides of the inequality, I am left with a negative 75 on the right side. And on the left side, I'm left with a negative 0.015n. And I need to determine what n is equal to. So I'm going to divide both sides by that 0.15. And if you remember your rules with inequalities, anytime you divide by a negative, your sign in the inequality will flip. So n will now be less than or equal to, and I want to divide that. I want to make sure that I do not mess this up for you guys. That will give me 500. So what I know is that n has to be less than or equal to 500. So it says the foundation can invest at most how much for at 4%? Well, at most can be invested if n is 500, n has to be less than or equal to 500. So that means that my 2n, which is going to be the same as 2 times 500, which gives me 1,000, which means that, guys, I just realized, let's back up. I'm not making a new video for this. We're going to erase. I realized that I missed something, and I'm hoping that you guys are screaming at me through the computer that you realize that I did something wrong. I did not put 5,000. That should be 5,000 there. So if my n is 5,000, then 2n is not equal to 2 times 500. It is going to be equal to 2 times 5,000. And it's okay to make mistakes. We're all human. So, okay. Which means that 2 times 5,000 is going to give me 10,000. So what you have to do with these types of problems, many times what students would do is they would get this value here and they will put that in as their answer. That's not your final answer. You determined what n is. N was invested at 7%. But the problem was asking what at most how much can be invested at 4%. Well, at 4% we had 2n. So 2 times n, 2 times 5,000 gives me 10,000. And just because, well, we don't really have the time, but from there, you could plug in that 5,000 there, and you could determine what that final amount would be invested at 5.5% interest. If you guys, if you have any questions with the problem that I just worked out, feel free to shoot me an email. I will be happy to clarify it for you. You guys enjoy the rest of your day.